Hello, this is Paul from Foresight Tech. In this lecture, we are going to do another application of integration. So, we're going to find the probability for normal distribution. And if someone learned the probability or statistic, you know, normal distribution is the most important distribution, right? So we look at what is the normal distribution. Okay, so if a random variable, a continuous random variable x follow normal distribution, mu is the mean, average, sigma is standard deviation, and we will have the PDF. The probability density function is here, right? Okay, somewhere you learned, and this exactly is a Gauss function or Gaussian functions we learned before, and that the integral is a non-elementary integral, right? Do you remember that? So it means we cannot find the elementary antiderivative for Gauss function. However, look at it. So this graph, if we draw the PDF, is very symmetric. The middle is mean, and the middle is high, and the both tail is low. This we call the normal distribution. Here, our purpose is going to define what is the probability for this normal distribution. So first, and the area, the total area under the curve, that's what, that's a improper, this is the third type of improper integral, right? So from negative infinity to positive infinity, or the area equals 1. Because f, and this integral, so we can, and for this f, we cannot find the elementary and antiderivative, do you remember? So we cannot give a proof here. However, wait to calculate 3. So definitely you will see another method. We're going to find this is exactly true. So however here, so our probability is this, okay? And the random variable is between A and B. If A is here, B is here. What's the probability? What's the chance? Okay, X will between A and B. And the other possibility x is from negative infinity to positive infinity, right? And in the probability theory, the probability is exactly, keep in mind that is the most important. And in probability theory, okay, the probability of an event exactly is the area under the PDF curve. Okay, the area is the probability. And we see now we have this question. We need to find the probability. In basic mathematics, means we need to find the area. How to find the area on the curve? That's the topic is in calculus 2, right? However, you know, fx we cannot find the we cannot find the elementary antiderivative because this is a Gaussian integral. Okay, you learned before. So what do we need to do? We need to do approximation, and we did a lot of approximation, right? So which one is the best among midpoint estimation and the trapezoid approximation and the Simpson? Okay, among these three at least, Simpson's approximation is the best, right? So we learned that before. And now we're going to give one example how to find the probability. And later we're going to compare the results we found with the calculator. Okay. Look at this example. If x is a normal distribution and the mean is 0, standard deviation is 1, which we call the standard normal distribution. Okay. How to find this probability x between negative 1 and 1? If someone learned statistics, what does this mean? This means one standard deviation from the mean, right? That means 0, negative 1, one standard deviation below to one standard deviation above. This is one standard deviation interval. And we have an empirical rule, which is around 68% of the data between, means this probability should be around the 68. Let me look at our answer. Our answer is 68.27%. Okay, exactly consistent with that. However, why we get this answer? So that's going to use Simpson's approximation. We have to approximate, okay, and n equals So here the questions ask us for this, because among the three we just talked about, Simpson's approximation is the best. Okay, and so you cut it 10 pieces, rounded to 4 decimal. Okay, so did the basic. Let's go into, so how do you do? The first, what the probability based on the definition is the integral, right? Means the definite integral for -1 to 1, and this is the PDF to integration, and it is a Gauss function, and the special this time you put the mu equals 0 and the sigma equals 1 into that PDF, you definitely find this. Okay, we will not go back to that. And then look at this coefficient, we can factor it out. This is a symmetry. Do you remember? -1 to 1. The function is exactly symmetrical about the middle. The middle this time, which means x equals 0, right? I mean this interval is from -1 to 1. Okay, and this function is even. This time is even function. Okay, means what? We only need to find the area on the right side, the right 0 to 1. We find the area, and then times 2, because both area are the same, right? Because of symmetry. Okay, and then we don't care about this coefficient. We care about this definite integral. You know, this time exactly that's Gauss, right? So we have the approximation. So we set up f. Okay, the function f is here. It's e raised to this power, and a is 0, and the b is 1. Now everything, and the n is 10, right? You know what we need to do. So we look at the formula first. We did this before. Okay, if someone you forget, so please pay attention. As 10, so we cut the 10 pieces. Is delta x over 3 times fx0, the first plus 4 plus 2 plus 4, that you remember the pattern, 1 4 2 4 2 go to 4, the last is 1. And if we have this table done, and later I still go back to show you how to use the calculator to get this value. Okay, we should before, okay, in the topic of approximation. So if we already have x, the value here, and then per log of x or the value put here. Okay, so we have everything, and per log into the formula we have everything. Due to calculation, we find as 10, the approximation for this integral is 0.8556, around the 4 decimal, right? Okay, the last, if we have this done, and the times the coefficient is the probability. See, I will see exactly the probability. So I said how to get this value in a very efficient way in the calculator. Use the table in the calculator. So I will show you a little bit later. So first, I will going to verify is this approximation as good as the calculator did. So first, let's going to see if the calculator also gives us this answer. Let me see my calculator. So my calculator is here. So mine is Texas 80, instrument 83. If you have 84, it's the same. Okay, it's very similar functions. So first, let's going to, do you remember? If someone you learn the statistic, okay, if someone learn the statistic how to find the probability between two numbers, we have a normal CDF functions in the calculator. I will going to use that calculator to verify if our calculation is correct or not. So where is the statistic? The normal CDF is going to distribution. Second, distribute. Wait, let me do a little for you. Okay, now it's clear. Let's go back. See, and the second this variance is distribution are going to distribution, and they go down to the second normal CDF. If someone learned the statistic, there is the functions. What is the input? The input should be A to B, the distance from the interval -1, 1, and then we need to show what the probability. There was the distribution is standard normal, which is mu the mean is 0, standard deviation is 1, and then parentheses. Okay, and I show you the results. See, and this is the calculator get what is hours. 0.6827, 0.68268, exactly consistent, right? Okay, good. And I clear everything. Now the last, if someone forget how to do Simpson, okay, in the calculator, so I'm going to show you again. So the first I type all these xi to the column L1. The second, so first we need to define what the function, right? I define the function, the first step. Second step, I will plug this value into L1. And the third step, I will apply the function into L1, and then I'll find this value, put it to L2. For the frequency, 1, 4, 2, 4, 4, like this, I put it to L3, and then we're going to analyze L2 and the L3, the two columns. Use the function in the calculator. We call the one variable stats, right? So the first, going to define the function. See, I already defined the functions in Y1. Okay, the second step, going to stat. I was going to input the data, added. See, I put the 0.1 or the dividing point xi into L1, okay, and then move it to L2. I'm going to the top. What we are going to do, I'm going to find the function upon, okay, and L1. The function is the variance. Go to right, y variance, which is function. Go down. The first y1 is the function, and then parentheses. This is the function, the domain is L1, right? Second 1, okay, and then parentheses. Okay, and see what I get. Exactly, I get the one I should do here. Okay, so that's what I get. Okay, what the fi? The fi now is in L2. What do we need? The frequency. So put it to L3. Do you remember the pattern? 1, 4, 2, 4. 2, 4, 2, I think I get it wrong. 2, 4, 2, 4. Okay, so 4, the last one. The second last one is 4, the last one is 1. See, that's the pattern. Okay. And then what do we need to do? One variable stats, which is in statistics. That again, going to the middle, calculator. One variable stats, and okay, this is the function. Where is the domain, or what is the function upon? We apply the function upon L2, our data, L3 frequency, also our data. So I need to get L2, second 2, comma L3. Okay, and this special format L2, comma L3. If yours is 83. Is similar. So first x list is L2, frequency list is L3. Okay, and then what do we get? We get the sum, 25 point. Okay, what did the sum mean? Let's look at it. Now what do we get is everything in these parentheses. Okay, this bracket, and then what do we need to do? This sum times 0.1 over 3. The sigma, the sum is 25.66875205, and then times 0.1 over 3. Remember this, and then what do we get? Exactly that approximation, 0.8556. 0.8556. We get it. That's all. Thank you.